services and base maps. Over to you, Jody.
Well, first of all, thank you very much. I do have to say that this presentation is actually brought to you by Andrea Amy, who couldn't be with you today. I took over a couple of his talks for material I was comfortable with or material I found important. So these slides are a little bit more detailed than I'm usually comfortable presenting, but I do find this topic very important, and I'm really fascinated and enchanted by all the innovation in this space. We'll talk a little bit about how GeoServer works with vector tiles today, both in terms of producing vector tiles and also consuming and styling vector tiles. So let me get started, and I might end up going a little bit too quickly. I don't know the pacing of this slide deck. Shout out, gesture or something. So the 5-minute intro to what a vector tile is. It's tiles. Most of the tooling is centered on this Web Mercator Google OSM pyramid, level 0, 1, 2, etc. But what goes into the vectors is not pixels. It instead is some kind of pre-processed data. So a vector format for delivering map-oriented data, not for editing, not for processing, but for display. So inside there, we're going to get vector shapes, we're going to get a geometry, and crucially, attributes. And the idea is that this allows client-side rendering. So the vector tiles are going to contain kind of raw or semi-processed information. And it's like we were doing our rendering chain and we stopped halfway through, and we shipped it over to the client, and then the client was able to proceed with the rendering chain. What I really like about this workflow is that we get the full high-resolution display output on the client side, and we also have the opportunity for doing really nice labeling and so forth. So here's what that looks like. OSM Lite, positron, and so on. How do we actually do that in GeoServer? A lot of these tool chains are going to be very similar in how they produce vector tiles. What we're going to do first is we're going to clip the geometry around a tile, but not quite at the tile boundary. We're actually going to do a slight buffer, and we're doing that so we can pull in any data that is going to be rendered in the inside of the tile. And then we are also going to simplify the geometry, because the geometries can be very detailed. So we're going to, first of all, we clip, and then we make a little grid roughly corresponding to the resolution we expect on the downstream device, and then we're going to simplify the geometry to that grid. So by doing this, we're going to produce a very small little snapshot of a geometry and the attributes in that region. So what about the features and attributes? A good vector tile is a really small one. We want to have as few features as possible in the tile, the minimum number of attributes. So one trick we use is we coalesce. We gather all the geometries with exactly the same output, and we force them into the same, the same row. So all of the features in this particular vector tile, even though they're individual buildings, have been combined into one single feature with a multi-polygon. So how does GeoServer go about producing vector tiles? Or how do you, using GeoServer, produce a vector tiles? We've been doing vector tiles since 2015. My coworker David Blasby did the first release. It is an active community module. It graduated to an extension in 2018, and it does see periodic investment. So the last significant improvements were done in 2024. This is a normal GeoServer extension you can download and install. How do we do it? Start by choosing the recommended grid set, Web Mercator Quad, and then you can choose what format. I've highlighted VND Mapbox vector tile. This is like the MIME type that the clients will download, but there's actually a number of different vector tile formats available in the mix. At some point there's like TopoJSON and other vector tile formats that GeoServer is in position to produce. So once you have that, and you go and you look at the GeoServer tile preview, you'll be able to see the vector tile. Now this shows up as a wireframe, and if you click on it, you can see the attributes that were gathered up for that vector tile. So that sounds all very well and easy, but I talked about feature coalescing and a bunch of other things earlier. How do you go about configuring that? And the answer is, how do you control the tile contents. We need to somehow adjust the level of detail for different scales. We want to filter what attributes are available, and so on. And we want to do that feature collapse, gathering several geometries into a single thing. And one more feature thing we need to accomplish is we actually need to choose a good label position. Because of the tile boundaries, we don't want to repeat the label in the middle of every tile. We actually want to generate a separate label point that looks good for the overall map. So styling to the rescue. Styling in GeoServer already has facilities for scale dependency and filtering features. You might already have styles developed in your organization for doing image output. The Mapbox vector tile engine just ignores the symbolizer part. It's not going to draw the lines, it's going to capture the geometry shapes and make them available for client-side rendering. We do have some vendor options, some extensions to the SLD core, allowing you to control attribute selection and feature collapse. So here's what that looks like using the CSS styling example. So first of all, we've got the road, then we've got the scale dependency, and then the attribute filter. So at this scale, we are only going to output the type highway. We do have to give the styling engine a hint, so we're saying stroke black. That's just so the engine doesn't ignore the style. It actually generates out the content. And then we've got these two vendor parameters, VT attributes. So we're only going to include the name in this output, and VT coalesce is going to combine all of the roads with the same name. Okay, and then here's a more exciting example with multiple layers. So you can see they're pulling in data from landmarks and roads and point of interest data, and all of this is going to be combined into a single vector tile that has multiple kinds of content. And that's an important capability. You can also produce this effect by turning on vector tiles for what's called a layer group in GeoServer, where you combine several layers into a single output. So how do we do this? How do you actually take output from GeoServer and put it into this XYZ ecosystem? So you grab the resource URL from the web map tile server capabilities, where it's got this little template, and you copy and paste it and you replace it with Z and Y and X. So this is the easiest way to go from the GeoServer, which is standards-based, to this XYZ app ecosystem. So here's a Mapbox example where they've copied the URL and they're able to see and start to style the results. So yeah, one thing that's interesting about GeoServer is rather than being limited to the Web Mercator output, you can actually generate vector tiles in any coordinate reference system. How do you go about doing that? You can see here they've selected a new output, Long Island Quad, and they've defined a couple grid levels. The next step is they're going to bind the grid set with a layer, so they're adding that to the tile server output. So you can see they've chosen Long Island Quad. Step 3, they're going to do that URL copy and paste trick like I talked about. And then they're going to start to configure their JavaScript client. So here they've defined the zoom levels that correspond with that grid set, and they're defining a tile grid with the correct resolutions. They're defining the right proj definition, and they're configuring open layers to put it all together. So you can see how it uses the tile grid and the projection from the previous page in a new vector tiles layer. And here's what that looks like. So this is a little recipe you can follow in order to take the content from GeoServer and use vector tiles in other coordinate reference systems. The other thing that I'm excited about, just in the larger kind of spatial data infrastructure story, is how GeoServer can consume vector tiles on behalf of other applications. And this allows GeoServer to make use of a lot of the cloud-native geospatial formats that offer such excellent cost efficiency for storing large data quantities. So to begin with, we've got this Mapbox tile store. So MB Tiles is an SQLite database that is full of tiles, and they can be vector tiles. This is a community module in GeoServer, and it actually exposes the vector tile layer as a vector layer. So on the fly, it stitches all the features back together so the normal GeoServer like WFS and other things can work. So it's a really kind of interesting approach. You can use GeoServer to break everything up into tiles. You can also use GeoServer to stitch everything back together. Why would you do this? Well, a nice thing is that you can download MB tiles available in the wild. So there's nice services that package up data and make it available for you. Here's one from MapTiler where you can log in and grab the entire world, or just grab like a bounding box and extract the information you need. Another one here, which is really new, it just came out in September, is PM tiles. So PM tiles, rather than being SQL-like database, is a single file, is compact, and it's one of these cloud-native formats, which means it can be placed on a web server, and it only reads forward using like HTTP skip, which allows a very cheap web server to be able to host that content, which we would otherwise have to host in PostgreSQL or a database. So this is a really nice addition to the GeoServer ecosystem. And in addition, you can actually store your MB tile file on any HTTP server, S3, an Azure blob, Google Cloud, some kind of cheap cloud storage. There's some of the connection parameters, but at the end of the day, it breaks down into the URL of where the information is located and some information about how much caching and so on is required to read that initial header. So here's an example of how you could get one of these things. There's a website here called Planet Tiler. It allows you to download raw OSM data, and you can use it to convert to MB tiles or PM tiles. So if you want to make one of these yourself, here's a tool you can use to do so. And then kind of putting everything together is something called MB Styles. So this is an extension for GeoServer that I'm very fond of. I helped lead the team that created it initially. So this is a JSON format for styling. It's been forked as the MapLibri project, and it's designed to work with vector tiles. So GeoServer has a basic understanding of it. You can see a little example here where content is being selected and styled as a line or a polygon here. Why you would do this is, well, you can download styles available in the wild, and there's a little website example here from GeoSolutions where they've got a worked example of how to configure GeoServer with one of these open map tile styles. And here's an example of GeoServer's rendering engine making use of these styles in different outputs. So this is styles that we've downloaded. We're running it through the GeoServer rendering engine on the server side, but the same style can be used on the client side for rendering vector tiles natively. So it's a very powerful story, being able to style once and use it for both server and client side. So why would you do this? So you might have existing clients that need raster tiles, package pre-existing older browsers. You might need to make a PDF base map. A GeoServer can render a PDF base map for you. You might be working in a sealed environment. You might need to do customization. You might need to work in a different coordinate reference system. Not everyone can use Mercator, and so on. So I really like this story of using GeoServer both to produce vector tiles, consume vector tiles, and then also style, use the vector tile styling formats natively within GeoServer. So it makes it it's a nice addition to your toolkit. How am I doing for time? So I think I'm almost done this content. So here's just an example from FOSS4G Europe earlier in the year, where we're rendering vector tiles in the local projection system. Okay, any questions? And I should thank Andrea for this content and all the work he's put into this technology.
Hi, I'm just wondering about the how, like the Mapbox vector tile style specification
Yep.
matches up with something like SLD and that kind of thing, and if there's any loss of, you know what I mean, like
I gotcha.
yeah.
So in some ways it's higher level in that you can define some like labeling things very simply that would take several vendor parameters with GeoServer to accomplish. And in other ways it's very low level because initially it was designed kind of more to be very close to WebGL and the front end. So it's a little bit hit or miss what abstraction it's at. GeoServer can convert from the Mapbox style to a normal SLD or the YAML representation YSLD from an original Mapbox style definition. Yeah.
Hi. Quick question. Do you, so MapLibre has been working on MapLibre tile format for a while, and we're hoping to release it. Well, we released it officially. We're working on all sorts of implementations for it now.
Yep.
Any plans?
We would love some funding. We've talked about this at FOSS4G Asia and Korea a couple of years ago. So I would love some time even just to rename the support we have from MB to MapLibre. But we really just need volunteers in our community in order to have capacity. So if you have any sponsors or time on your hands, please send them our way. And excellent work, by the way. It's lovely to see that technology progress.
Hello, I've been playing around with MB style quite a lot, and is it at the moment that it goes to the Mapbox version 0.1 compatibility? So I've been playing around and try to use some of the newer style, and there are things that like line with gap or line gap with, I can't remember.
So you see this person in front of you that just talked about MapLibre?
Yep.
You need to go and buy him a beer, and he'll explain to you about open standards versus closed standards.
Yep.
Okay.
Yep. I was wondering if there's any work that we can contribute to.
I'm not sure if it would be that ethical for me to start reverse engineering their format. I'd much rather go with the open solution as represented by this lovely man.
Thank you.
Yeah. So that's more a question of ethics rather than technical ability. Yeah. Anyone else?
Sorry, just a question about tile caching is enabled.
Tile caching?
Yep.
Yes. So the little screens I brought up briefly, that was from when you go to GeoServer and you say, please cache my tile, and it says what formats, and you say PNG, and then you go, oh no, I actually want vector tiles as well. And the tile caching machine called GeoWebCache doesn't really care. It's just going to save the bits and send them out afterwards. So
Thanks.
It can't tell the difference between vector tiles and JPEG. Yeah. Thanks.
One more question here. We've still got some time, I think.
Yeah, that's what I get for finishing early.
Thank you. It's amazing to see all these things. I might derail a bit.
Go for it.
What do you think about 3D tiles and support in GeoServer?
So I think people have actually, people do use GeoServer to like serve up 3D content. I'm not sure if there's been, actually, hold on. There was like some like whirlwind thing, an extension for GeoServer that did some 3D tiles. I'm not sure if it's still maintained, but people certainly have done 3D tiles for that whirlwind extension. I just personally haven't, but I encourage anybody who wants to. Yeah. Okay.
Any more questions?
Well, thanks, everyone. Please enjoy the rest of the session. I have to go to another room where I'm going to talk about probably my most important presentation, which is about like security vulnerabilities and direction for software folks trying to adjust to regulation around the world. So I will leave you.
Please join me in thanking Jody.